dengan kerjasama Kementerian Sains, Teknologi, dan Inovasi Sabah dengan kolaboratif Institut Pendidikan Guru Kampus Tuaran Sabah dengan berteraskan slogan segera menerajui perubahan. Saya dan selaku moderator pada hari ini, saya akan menemani hadirin semua sekalian serta pada hari ini, yaitu raising questions and changing non-investigable questions to investigable questions. Bagi memulakan program kita pada hari ini, baiklah terlebih dahulu untuk kita mulakan dengan bacaan doa bagi memberkati program kita pada hari ini. Oleh itu, majlis menjemput Ustaz alias Haji Idris untuk membacakan doa. Majlis mempersilakan.
Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala Sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Segala puji dan puja hanya untuk Tuhan sekalian alam. Selawat dan salam atas junjungan besar Nabi Muhammad sallallahu alaihi wasallam, ahli keluarga dan para sahabatnya. Ya Allah, ya Tuhan kami, Tuhan yang menguasai langit dan bumi, hanya padamu kami panjangkan kesyukuran atas segala rahmat dan berkah-Mu ke atas kami. Ya Allah, ya Hayyu, ya Qayyum, kami memohon inayah dan taufik-Mu. Kurniakanlah kesejahteraan dan kebahagiaan serta kesehatan jasmani dan rohani. Bukakanlah hati-hati kami, lapangkanlah dada kami untuk menerima ilmu pengetahuan serta bimbingan dalam melaksanakan tanggungjawab kami. Ya Allah, ya Rahman, ya Rahim, kami memohon dengan kudrat dan iradah-Mu, kurniakanlah kekuatan dan ketabahan dalam menjalankan tanggungjawab kami, dan anugerahilah kejayaan dan kecemerlangan kepada kami dalam semua bidang yang kami ceburi. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqna min ba'di tafarruqan ma'suma wa la taj'alillahumma fina wa la ma'ana wa la man yasbahuna shaqiyan wa la matrudan wa la mahruman. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Walhamdulillahi rabbil alamin.
Terima kasih diucapkan atas bacaan doa sebentar tadi. Baiklah, sebelum saya mempersilakan penceramah kita pada hari ini untuk meneruskan slot, eloklah dahulu untuk kita mengenali serba sedikit biodata penceramah kita pada hari ini, kerana tak kenal maka tak cinta. Encik Tan Cho Chew kini bertugas di Jabatan STEM Institut Pendidikan Guru Kampus Ken. Beliau memiliki ijazah sarjana pendidikan sains dari Universiti Malaysia Sabah iaitu UMS dan ijazah sarjana muda sains dengan kepujian dari Universiti Campbell, pengkhususan dalam biologi dan kimia. Beliau merupakan seorang guru kimia sejak tahun 1997. Beliau juga merupakan penulis modul Doing STEM in Science, perunding program Dual Language DLP di peringkat kebangsaan dan jurulatih dalam pendidikan sains berasaskan inquiry IBSE. Encik Tan telah mengadakan beberapa kursus latihan jurulatih TOT untuk IBSE kepada guru-guru di peringkat negeri dan kebangsaan. Oleh itu, tanpa membuang masa, saya menjemput Encik Tan Cho Chew untuk menyampaikan ceramah beliau. Majlis mempersilakan.
Baiklah, terima kasih saya ucapkan kepada saudari moderator, saudari Tan Yi Xing, yang sebenarnya merupakan pelajar saya di IPG Campus Ken semester 2 PPISMP. And I'm teaching her chemistry, fundamentals of chemistry 1 and 2 for our foundation course. Terima kasih juga saya ingin sampaikan kepada Ustaz atas bacaan doa tadi. Sebelum kita mulakan, saya ingin juga mengucapkan selamat petang kepada SISC Plus, iaitu Puan Sylvia Meeting Pakoy. Halo Puan Sylvia. Beliau juga merangkap pengerusi Carnival STEM FIESTA 2022. Selamat petang juga diucapkan kepada guru, ya, antaranya ada yang memang merupakan TPU, tenaga pengajar utama, ya, untuk IBSE. Antaranya ialah Cikgu Alice. Hello Cikgu Alice. Ya, dan saya nampak juga Dayangku Rohani. How are you Dayangku Rohani? Yang juga merupakan, ya, TPU. Dan ramai guru yang saya kenal juga kerana pernah pergi mengilir praktikum di sekolah anda. Contohnya Puan Evelyn. Ya, hello Puan Evelyn. Alright, okay. Guru-guru, semua guru-guru yang mengikuti sesi ini, ya, tuan-tuan dan puan-puan. Dan tak lupa juga pegawai-pegawai, ya, PPD Daerah Tuaran. Ya, selamat datang, ya. Okey, saya akan share sedikit input, ya, tentang raising questions. Dan sebenarnya slot saya ataupun input saya terdiri daripada soalan guru. Ya, soalan yang diajukan oleh guru kepada murid dan bagaimana guru menggalakkan murid, ya, bertanya soalan, khususnya soalan investigable. Ya, investigable questions or testable questions. Okay. Sepanjang sesi ini, I will be using both English and bahasa Melayu. So, izinkan saya gunakan bahasa Inggeris juga. Ya. Alright, so I will start with raising questions. Obviously, is one of the practices, yeah, in science and engineering. And according to BIB 2011, science and engineering in fact share these 8 common practices. Yeah, and obviously asking questions is one of them. Yeah, asking questions is the basis of inquiry. Okay, so asking questions is obviously one of them. Defining problems, developing and using models, planning and carrying out investigations. And this is in fact from the question, yeah, from the investigable question, which leads to investigations. And of course, analyzing and interpreting data, using maths and computational thinking, and the students, all right, ideally they will be involved in constructing explanation and designing solutions, which leads to knowledge construction. Ya. Mereka membina ilmu, ya, daripada penerokaan yang secara hands-on. Ya. They will be engaged in arguments from evidence, yeah, obtaining, evaluating, and communicating information, right? And with this, we can also promote the 6 C's. And of course, we all know what are the 6 C's, yeah? Okay, so next. Okay, questions, they are the basis of inquiry, yeah? Questions are the basis of inquiry. So I will start off with questions from the teachers. Yeah, questions from us. All of us are teachers. So when I enter the class, when I entered Yixing's class this morning, right? This morning, so I will be asking them, what have you learned? Very simple questions. What have you learned? And I will ask them to tell me, yeah, what they have learned. So they will be saying something and the teacher will add on, which leads to more and more things. Yeah? More and more will come out from the students, yeah, not from the teacher. Yeah, but of course the teacher must have the skill to facilitate so that we get more and more from the students. And of course, we do not judge, but we murnikan respon pelajar kita. Alright, so questions are the basis of all inquiry, and teachers' questions are very important. Yeah, teachers' questions are very important because if we ask questions effectively, okay, we actually direct our students' learning. Boleh kan? We direct students' learning. And at the same time, we stimulate students to actively construct their knowledge, yeah, based on the questions we ask. Therefore, I believe you agree with me. When the teachers have very strong content knowledge, they will be able to ask questions that stimulate their students to construct knowledge related to the topics. Yeah? Okay. So as a result, teachers must have good content knowledge. All right. And that is the reason why the PPISMP students, yeah, are my students. My PPISMP students and my PISMP students, of course, throughout their course of studies, they are given not only pedagogical skills, yeah, they are not only taught pedagogical skills, they must be trained so that they have good content knowledge before they go out to the school. Okay. So teachers must ask productive questions. Okay, next slide. What are productive questions? Yeah? Productive questions have become one of many effective teaching strategies. Yeah? So it is very important that teachers ask productive questions. Okay? Questions from the teachers. And productive questions are questions that teachers or students can ask that produce an answer. Of course, students can also ask productive questions. All right? So these type of questions will give an answer, not only sometimes verbally, but also it can be shown by the student physically, and it can be even recorded in the science notebook. I think you have a session on science notebook, and in the science notebook, the students leave the answer in the notebook, not only in the written form, but in many other graphical representations or any drawings that they can understand and that they can use for effective revision. So it's okay. Give them the freedom to write, give them the freedom to draw, and it is an important platform whereby we can know the knowledge of our students. And we are able to detect misconceptions from their science notebook, and then we can bridge the knowledge gap. So that is something about science notebook from teacher Alice. She emphasized a lot on science notebook, and I also told my trainee teachers about science notebook at my campus. All right, productive questions, they are not yes or no questions. So if I ask my students, what have you learned? Instead of asking them, for example, instead of asking Yixing and her classmate, did you learn about solubility product? I will not ask that because they will just give me a yes or no answer, right? So productive questions are not yes or no questions or low level, okay? So instead, I will ask them, what have you learned? And maybe they will tell me soluble salt and insoluble salt. And then I will continue asking them, can you tell me the 2 classes of soluble salt? And for each class, what are the methods for preparing that group of salt? Yeah, something like that. So it is definitely not a yes or no questions. Yeah, factual recall questions. I try not to ask factual recall questions. All right. Productive questions help in the construction of student knowledge. Help students to make connections between prior and new experiences. And this is very, very important. Questions that are able to connect what the students have learned, what the students have experienced, and what are we going to teach for today. All right, and help in the development of students' curiosity, because once their curiosity is sparked, they are more ready to immerse in the lesson. Okay, so any questions so far? Any productive questions from any one of you? Jelas tak? Cikgu Cindy. Kita lebih interaktif lah kan? Cikgu Cindy, Cikgu Evelyn.
Ya, Mr. Tan, jelas.
Jelas.
Ya.
Cikgu Fauzia.
Boleh.
Okay, so far so good. Okay ya, so saya sambung. Okay, so there are 6 groups of productive questions. So I would like to share with you the 6 groups of productive questions. Okay, 6 groups. Okay, you must ask attention focusing question. Yeah, attention focusing question. Okay, next slide. The first group, because when we ask attention focusing questions, we help our students to fix their attention on very important or significant details. All right? Okay, so I'm sure you have asked this type of questions. Yeah? Have you seen rafflesia before? Because you want to talk about rafflesia. Okay, what have you noticed in the picture? You are actually bringing in a picture of a view in a forest whereby there is a rafflesia, for example. Okay. What are they doing? Yeah, you show them a video clip. You ask them, what are they doing? Okay, or you are bringing, or you bring in something for them to observe, and you may ask, how does it feel? How does it smell? How does it look? Yeah. All right. Okay. And the next group is measuring and counting questions. And this group of questions require students to become more precise about their observations. Yeah? For example, how many gas bubbles are released in half a minute or in 30 seconds? So they have to observe the change, and they can calculate the change, the rate of or the volume of gas collected, over half a minute. So they become more precise, because you ask measuring and counting questions. They have to observe the change, and they have to calculate or measure the change. Okay, how often, how long, how much, and so on. Yeah, so these are examples of measuring and counting questions. So the next group is comparison question, and this will enable our pupils to do an analysis. Yeah, help them to analyze. Okay, so we ask compare and contrast. Okay, for example, yeah, compare the principles of electrochemical cell and electrolytic cell. After teaching electrochemical cell and after teaching electrolytic cell, we would like them to analyze and to compare and contrast. Yeah, and also they will be able to do classification accurately. So help students to analyze and to classify. Okay, and action questions encourage our students to explore or to make predictions about phenomena. Okay, what happened if? What would happen if? All right, that's how we ask. And these are the question stems. What if? What if? Okay. What if we add more enzyme? Okay, what if we increase the concentration of the acid? Something like this. What if we change the physical state of the catalyst? What if we change the amount of catalyst and so on? Okay, Leon, next. And the last two groups are problem-posing questions. Yeah, problem-posing questions help students plan, and they will implement solutions to problems. Now, this is very important because of our emphasis of inquiry. Emphasis of inquiry, emphasis of thinking skill, right? Nowadays, we emphasize on thinking skill. We emphasize on inquiry-based learning. And what else? We emphasize on scientific investigation, right? And we want science to be taught like that, to be taught in this way. So we must ask problem-posing questions. Okay, and the last group is reasoning. Okay, reasoning helps students to think about experiences, and then they construct ideas that make sense to them. Think about experiences, construct ideas that make sense to them. Example of question stems include: what do you think? What is your reason for? And can you invent a rule for something? Okay, now, next, I would like you to watch a video. Leon, next. Yeah, video. Okay, so relax, watch the video. Okay, all right. And I would like you to jot down, to write down the questions posed by the teacher in the video, and see whether you can detect the 6 groups of questions. Okay, what are the 6 groups of questions? Okay, remember the 6 groups of questions? Okay, attention focusing question, comparison question, measuring and counting question, problem posing question, action question, and reasoning question. So relax, watch the video. After that, Yixing, we will have a break. Okay, and during the break, you can see whether you can detect all the 6 groups of questions. Okay, and we will have a short discussion before going to the next part. And the next part is actually students' questions. All right? Okay. Leon, please. Video clip.
Ce matin, une expérience scientifique vous a été proposée, d'accord? On a appelé situation 1. Est-ce que quelqu'un dans la classe peut nous rappeler en quelques mots quelle était cette situation, ce que vous avez observé, constaté, et les hypothèses émises par rapport à cette situation? Tu vas essayer, Alexis? Oui. Ah, ouais. Allez.
Ce matin, on a fait une expérience. On a pris comme matériel, on a pris une bougie, un briquet et un récipient, un contenant. Et on a observé qu'on a allumé la bougie. Après, on a mis le contenant au-dessus de la bougie, à l'envers. Et la bougie s'est éteinte en quelques instants.
Quelqu'un d'autre veut passer après au constat, ce qu'on a noté? Oui, Charlotte, tu prends le relais? Merci, Alexis, bravo pour les efforts, c'est très bien.
Alors, ce matin, on a aussi aimé poser des questions ou trouver des hypothèses. Pourquoi? Quelle réaction aurait la flamme avec un contenant plus grand et en combien de temps s'éteindrait-elle? Première question, donc après on va valider plus tard. On va valider. Voilà.
Quelqu'un veut prendre le relais peut-être? Non? Allez, Daniel, vas-y, très bien, voilà.
Cette séance qui se déroule dans une classe de CM2 établit un lien entre les sciences et les mathématiques par l'utilisation faite de données recueillies lors d'une expérience.
Alors, on s'est posé beaucoup de questions. Alors maintenant, vous allez vous lever, je vous proposerai une situation numéro 2. Que va-t-il se passer si je change donc de contenant? Oui?
La bougie va rester un peu plus longtemps parce que déjà, c'est vrai qu'elle est toujours plus alimentée, mais elle a quand même une plus grande place, donc elle peut plus prendre d'air avant de complètement être à bout de souffle.
Par exemple, autre hypothèse, on y va, hein, de toutes questions possibles. Oui, Willy?
Qu'il y a tellement plus d'air que dans le petit récipient. Dans le petit contenant que la durée de la bougie va durer plus longtemps.
Comment on va vérifier ça? Avec quels outils? Avec quels moyens? Comment on va s'y prendre? Et moi, ce que je vous propose, c'est maintenant, dans chaque groupe, vous réfléchissez, comment on va s'y prendre. D'accord? Comment on peut prouver ça? Comment on peut faire la démonstration? Et puis après, eh bien, ensemble, eh bien, on va vérifier si ça fonctionne. D'accord? On réfléchit? Prouver. D'accord? Oui.
Alors on va allumer la bougie et on va la faire, on va retourner un contenant pour éteindre la bougie. On va mesurer le temps que met la bougie à s'éteindre et ensuite on va voir lequel contenant a le plus d'air.
Par exemple?
Hypothèse 1. Vu que le contenant est plus grand, la bougie peut s'alimenter plus longtemps car il y a plus d'oxygène. Hypothèse 2. La bougie fera une grande flamme dans le contenant.
Si on veut là prouver quelque chose, comment on va s'y prendre? Ou autrement dit, qu'est-ce que ça met en relation là dans cette phrase-là? Qu'est-ce qui est important? Ce qui semble important? Certains l'ont trouvé d'ailleurs. De quoi parle-t-on dans cette phrase-là? Oui?
De la flamme.
Alors, donc de quelle notion?
De la réaction de la flamme, enfin comment ça va se passer, comment la flamme va
Oui,
évoluer.
d'accord.
Le temps et...
Donc là, il y a peut-être une question de temps, hein, c'est peut-être ça qui va bouger. Et puis,
l'alimentation de la flamme, d'oxygène, enfin l'alimentation.
donc là, l'hypothèse, c'est certainement que plus le bocal va être grand, plus... D'accord, c'est bien ça, hein?
Il faut tout d'abord chronométrer la bougie dans le plus petit récipient et chronométrer la bougie dans le grand récipient. Les bougies qui sont à la même hauteur de nez.
Pour savoir si le gros, il y a la même distance, enfin il y a la même quantité d'oxygène dans les deux ou pas.
Est-ce qu'on ne pourrait pas commencer par mesurer peut-être déjà le temps que met la bougie? Voilà, c'est bien ce que vous avez dit, en fonction de la taille du récipient. D'accord? Alors, on va faire un petit tableau rapide. Et là, qu'est-ce qu'on a fait? On a mesuré
Le temps.
le temps. Avec quelle unité? Le temps en quoi? En secondes?
En
Dans
seconde.
Allez, vous êtes prêts?
De toute façon, c'est seulement quand je mets le... On va la laisser.
Bon.
1, 2, 3.
Laisse passer les 30.
Toujours le top. Le départ, top de fin. Oui. Allons-y.
Top. Tu peux lâcher.
Oui, c'est bon, Willy.
Ouais, moi aussi, ça.
Là.
Alexis,
Mais il n'y a personne qui a dit stop.
Pile.
Il n'y a personne qui a dit
On n'a
stop.
pas vu la fumée.
Si je l'ai vu. 34, 6.
0,6 ou 6? Ah, 0,6, d'accord. Et toi?
34 et 93.
Ah oui, donc toi, c'est plus près de...
34, moi j'ai 35, 24, 6.
On l'arrondit à 34. Normalement, c'est bien faire un choix. Et le dernier? Alors,
Pour le dernier, il en faut.
tiens, Damien.
Pour le dernier,
Parce que, attention.
Top.
Celui-là, ça va pas.
Non, c'est bon.
Ouais, Marius, ça?
Oh, c'est bon.
Top. Oui. Top. Exactement même temps qu'il a filé.
99.
Donc presque 44.
43, 64.
On prend un 44.
Oui.
43, 78.
Maintenant, on a bien montré que plus le contenant est grand,
Plus ça met du temps à...
d'accord. Le temps, on l'a mesuré, donc on a été précis. Maintenant qu'on dit plus le contenant est grand, cette notion-là, est-ce que vous en pensez? Est-ce qu'elle est précise, cette notion-là? Alors qu'est-ce qu'on pourrait faire maintenant, peut-être?
Leur taille,
Alors.
mesurer leur taille.
Alors comment mesurer, là? Comment on s'y prend?
Avec une
Oui.
rayure.
Je me souviens plus si c'est le rayon ou le diamètre pour,
Le rayon.
pour la...
Oui. Mais qu'est-ce que tu veux mesurer, là, donc?
on mesure
Mais-
sur la hauteur et puis la...
Oui, mais
Sur...
est-ce qu'on sait faire ça?
Non.
Alors, qu'est-ce qu'on pourrait peut-être utiliser dans tous nos outils, ce qu'on sait, dans nos connaissances, pour mesurer les différentes tailles, entre guillemets, hein, de ces contenants?
Avec un bécher,
Comment ça, avec un becher?
on met de l'eau dedans jusqu'à
Oui.
jusqu'à ras-bord et,
Oui.
puis après on mesure avec le
Donc on
bécher.
mesure quoi, en fait?
On mesure la contenance.
On sait faire ça ou pas?
Oui.
Alors? Si on faisait ça? Peut-être.
Allez, là, il y aura...
Là, vous en êtes à combien pour l'instant?
Là on en met à 400 plus 400 plus 400 plus 120 plus 40.
D'accord. Ok.
800, 1360 on met.
La base est faite.
Allez, je le prêt.
C'est deux j'ai eu.
Ici, là.
On a la même.
La base est en cours. Et ici. C'est-à-dire. C2, donc on vous écoute. C2. 250 millilitres. Oui, tout à fait. Ensuite,
130 millilitres.
Ouais, 130.
donc ici 1380.
J'ai mis ça.
En CC, c'est quoi?
C'est 5.
C'est 5.
Oui.
Ouais.
570.
Ah bah ouais, j'avais oublié plus de 15, ça fait bien 700.
On se recentre un petit peu, venez après moi. Regardons, si vous me permettez, un instant, le résultat du travail engagé. On a bien ici un ensemble de données, d'accord? Ok. Ici, l'évaluation du temps sur les différents contenants, et ici, de leur contenance, d'accord? Quand on observe ce tableau, est-ce qu'il n'y a pas une remarque qui vous vient à l'esprit par rapport à la question initiale? Oui, monsieur Marius.
Je trouve que c'est équitable.
Alors, qu'est-ce qui est équitable là, Marius?
Bah, le temps que la bougie reste dans le contenant,
Et ça,
selon
tu...
l'envergure du contenant.
Oui, et si on va plus loin, quand on regarde tout le tableau, monsieur Tom?
plus la contenance est grande et plus le temps est grand aussi. Plus la taille des contenances sont grands.
Comment on pourrait reformuler ça?
Plus le bocal est grand, plus ça dure longtemps.
Le temps que la flamme s'éteigne dure plus. Plus la contenance des bocaux sont grandes et plus le temps est grand.
D'accord? C'est clair? Ouais. Bien. Une fois qu'on a cet ensemble de données numériques là, qu'est-ce qu'on peut en faire maintenant? Anaïs?
On peut le mettre en graphique. En schématisant.
Et en graphique, on sait faire ça ou pas?
Bah oui.
Qu'est-ce qu'on pourrait faire?
On pourrait le faire en bas.
En plus, on a.
Alors en bas, sur la... Oui, d'accord. Sur deux courbes?
Oui, la courbe, elle va pas être régulière, mais elle va monter.
Oui, elle va monter.
Et à ton avis, elle va pas être régulière?
Non, non,
Ouais.
non.
Non?
À la vie, n'a pas les mêmes boules.
Alors, on va essayer avec un graphique ou pas?
Oui.
Là, je mesure. 500.
On a fait les graduations pour le temps.
Oui.
Le second, on ne sait pas comment faire pour...
Alors, on a 1380 millilitres. Si on prend 1 cm égale 100 millilitres, donc 10 cm.
1000 millilitres.
Oui. Et après, donc est-ce que c'est possible ça? Oui. Donc tu sépares là, tu marques par exemple là 100 millilitres, puis au deuxième 200, d'accord? Essaie de repérer après. Est-ce que je veux dire ou pas? D'accord? On essaie de faire ça ensemble? Alors, comment partager tout ça? Ah oui, donc on trouve peut-être ça plus simple. S'il vous plaît, lorsqu'on observe ce graphique-là, qui donne une certaine lecture de nos données numériques, là, qu'est-ce qu'on peut en conclure? Regardez bien ça, c'est intéressant. Oui.
C'est un graphique proportionnel.
Oui. Oui, donc il y a effectivement, entre le temps et la contenance, il y a bien un lien, d'accord? Donc là, c'est, on peut dire à peu près. À peu près. Oui, c'est quasi linéaire, donc il y a une situation de proportionnalité, d'accord? Ok? Ma femme m'a offert un beau vase de 1000 millilitres. Et moi, je voudrais savoir si je mets une bougie, d'accord, que je recouvre la bougie de ce vase, combien de temps, à votre avis, la bougie va mettre pour s'éteindre? Marie?
Entre 30 et 40 secondes, je pense. Oui.
D'accord. Alors, regarde dans le tableau, comment faire pour peut-être être encore plus précis. Oui.
On pourrait s'aider de la mesure du contenant 2. Comme c'est 250, on multiplie les deux mesures par 4.
Et donc, ça donnerait?
Ça fait 32.
Est-ce que ça fonctionne?
Oui.
Bon. Vous êtes d'accord? Si j'ai ce problème-là, 1000 millilitres, c'est bien 4 fois 250 millilitres. Donc, multiplié par 4 le temps. Donc, on a fait un travail qui est à la fois précis et qui mériterait peut-être encore
Peut-être une validation
supplémentaire. D'accord? Ça vous va ça?
Je crois que les enfants ont eu un grand plaisir d'être dans l'action, de faire les choses eux-mêmes, de manipuler, de travailler à la fois en petits groupes, en grands groupes, individuellement, de mettre en jeu toutes ces compétences qui, pour eux, va leur donner du sens. On a pu observer là, manifestement, que les enfants, certains enfants, qui sont vraiment en difficulté,
All right. So a lot of questions, yeah, from the teachers and also from the students. So can you give one question to each group? Yeah, there are 6 groups of questions. Okay, try to give one question to each group. Yeah, during the break. So I will see you again, let's say at 2:55. Is it okay? 2:55. Okay. Would you like to watch the video again? You can actually chat with me at the now only I saw Mr. Cikgu Azman. Hello, Cikgu Azman. Okay, you can chat with me. You can drop your messages at the chat. All right. Do you want to watch the video again? It's all right if you do not want to watch again. Okay, so try to give a question for each group. A question that you have got from the video. Okay, all right, so I'll see you again at 2:55. Is it okay, Yixing? All right, okay, so see you then.
Baiklah hadirin sekalian, kita akan berehat sebentar selama 3 minit sebelum kita teruskan slot kita pada hari ini. Sementara kita berehat, mari kita menonton video iklan IBSE yang akan ditayangkan.
Alah, saya ni mau ajar ni. Ini macam 6. Ini pun okey. Tapi macam susah pula, tidak mau juga ni.
Tenang kawan, semua benda ada penyelesaiannya.
Anda rasa buntu? Jangan risau, jangan gundah. 14 slot IBSE kan ada. Benar cikgu, jom ikut, jangan ketinggalan. Rugi tau.
Wow, jom apa tunggu lagi? Kamu mau tahu apa itu sains?
Anda perlukan ini, My Science Notebooks.
Anda perlukan teknik penjualan yang betul. Ini atau ini.
Apa itu? Itu. Jom ikut. Kamu tahukah apa itu eksperimen? Kalau tidak tahu, mari saya tunjuk.
Document based research.
Nak tahu? Jom ikut. 17 Mei 2022.
Projek interdisiplin. Ish, macam tak pernah dengar pun. Apa ya? Jom. Nak tahu?
Tools for enhancing inquiry. Apa tu? Okey, nak tahu lebih lanjut? Check it out.
Anda nak tahu tentang pentaksiran dalam IBSE? Jom ikut saya.
Teknik penyoalan guru. Apa benda tu? Jom.
Video analisis.
Kami sedang buat. Anda tidak lagi. Jom.
Kamu mau tahu tentang lesson planning? Pak, jom. Jangan kasih lama.
Barang sumber IBSE. Nak tahu? Jom ikut slot ini.
Oh, ya. Banyak pula slot-slot yang menarik ini. Apa lagi susah hati? Mau sedih-sedih? Ikut perkongsian sahaja.
Hadirin sekalian, link kehadiran akan diberikan pada akhir program kita pada hari ini. Diminta hadirin mengisi pengesahan kehadiran pada akhir program. Baiklah hadirin sekalian, marilah kita kembali kepada slot Raising Questions and Changing Non-Investigable Questions to Investigable Questions yang akan disampaikan oleh Encik Tan. Majlis mempersilakan.
Okay, welcome back. Okay, welcome back. Alright, now sebelum saya teruskan dengan raising question from our students. Okay, something. Okay, maybe we would like to see what questions that you have detected from the video just now. Yeah, attention focusing question. Can you give me one attention focusing question? Anyone? You can leave your answer at the chat room. Boleh? Cikgu Maisin ataupun mana-mana. Measuring and counting question, comparison question, action question, problem posing questions, reasoning question. Okay, tiada? Tiada? No response, susah sebab di alam maya. Ada. Okay, Cikgu Azman. Teknik penyoalan boleh, ya, tetapi ini adalah lebih kepada productive questions. Tetapi di dalamnya ada teknik jugalah, ya. Questioning teknik, ya. Boleh? Yang lain? Thank you, Cikgu Azman, for your response. Oh, perlu kepada BBM atau tidak? Ya, satu soalan yang sangat bagus ya. Biasanya kalau kita ada BBM, di mana murid dapat observe, okay, di mana murid memerhati, itu boleh membantu mencetuskan soalan. That means you provide the stimulus. Okay, and it will stimulate the questions from students out of their observation. Ya, jadi membuat pemerhatian dan pemerhatian mereka mencetuskan soalan. So bagus, ya, bagus ada BBM. Okay. Did I answer your question, Cikgu Azman? Adakah soalan Cikgu Azman dijawab oleh saya? Okay, thank you very much. Okay, baiklah. Okay, now walau bagaimanapun, ya, kita telah lihat satu rakaman video di mana guru itu bertanya dan murid juga bertanya, ya, untuk mendapatkan ilmu. Ya, so kita ingin melihat, ya, sesuatu yang sebegitu berlaku, ya, dalam bilik darjah kita, ya, khasnya untuk mata pelajaran sains, ya, supaya kita dapat promote, ya, inquiry based learning, ya, di mana kita cuba meningkatkan aktiviti yang berpusatkan murid, ya, di mana murid membina ilmu dan mereka facilitated by teachers' question, and the teachers' question also make the students ask more and more questions. So I will be looking at raising questions from the students, all right? And in fact, this is one of the most powerful ways for our students to learn science. Yeah, because the questions are grounded in their own curiosity. Okay, we stimulate curiosity. Okay, we elicit students' questions. Kita cetuskan murid supaya mereka tanya soalan. Okay, and we move them in productive directions. Ya, kita membawa mereka. Ya, kita membawa mereka ya ke arah mendapatkan ilmu ya ataupun kemahiran. So we move them in productive directions, and ultimately we actually lead them to investigation. And from the investigations, the students construct the knowledge. So that is what we actually want, yeah, to get this done in a science classroom. All right, all inquiry begins with a question, yeah, and as Cikgu Azman has now I see Cikgu Azman question at 302. Okay, yeah? All right, I will continue and get back to you, Cikgu Azman. Okay. I'm so glad that I have Cikgu Azman yang tanya banyak soalan. Okay. So, seperti yang ditanya oleh Cikgu Azman, many teachers use KITS, KITS. Dan Cikgu juga guna dokumen-dokumen sebagai starting point untuk mendapatkan soalan daripada murid kita. So, sememangnya kita perlu BBM. Ya, kita perlu BBM. Kita perlu dokumen yang content related. Ya, kita perlu kits actually. Ya, so ramai guru yang berusaha menghasilkan kits yang bersesuaian dengan murid mereka. Ya, melalui inovasi. Alright. Okay. So, Leon. Next slide. Okay. Now we know that our students should be motivated to explore certain topics in greater depth. Yeah, if they could pursue their own questions. Yeah, that means they will be actively involved in looking for answers to answer their own questions. All right. However, sometimes we are very hesitant to do that. Ya, saya pun mengaku ya, sebab saya pun guru dahulu. Kenapa? Because we are worried that our students may not have any questions, or they may not have many questions, and their questions may not be focused on the topic at hand, all right? And their questions may not be possible to do an investigation. So don't worry. It is our part to convert their questions. Okay, so we will be talking a bit. I will share with you how are we going to convert non-investigable questions to investigable questions so that the students can plan an experiment, for example, or any investigation. Yeah, experiment is just one way to find answers to the question. All right, so we help them to fine-tune their questions. Okay, but don't get me wrong. It doesn't mean that non-investigable questions are not important. there is always a combination of non-investigable and investigable questions, yeah, depending on the context. However, if we see that there is a chance to convert non-investigable question to investigable questions, which will lead to further investigation by the students, for example, through scientific method, kaedah scientific, we must grab the opportunity. And together with the students, we convert the non-investigable questions to an investigable questions by doing what we call variable scan. Yeah, boleh ubah. All right, so I will talk about this, okay, until the end of this session. Okay, Leon, next slide. Okay, next slide. I have, okay. So obviously, this is one of the best ways we can help our students understand a concept. Yeah, we teach them how to voice their questions as they learn. And it also gives us an opportunity to address areas our students have not yet understood or maybe wrongly understood. Yeah? It also promotes rich opportunities for classroom discussion, as what you have seen in the video. Yeah? There was active discussion, but the teachers always ask productive questions, which leads to more questions and more answers. Yeah? Okay, next. Leon. Okay, now it is very important, yeah, because asking questions can both motivate students and encourage them to approach topics with curiosity. Yeah, they ask something that they want to know about, and they do something to find out the answers to their question. Okay, and because of that, they are more likely to understand new materials if they ask questions. All right. It allows students to engage in two-way communication with us. And this is what we want, two-way communication. And it can help us to pinpoint any gaps in their understanding. Okay, next. But how are we going to encourage our students to ask questions? Okay, first, next slide. We must make sure that our classroom environment is a safe place for them to ask questions. Now, why do I say so? Because we must make them feel well that their questions are always welcome. Kita selalu mengalu-alukan soalan daripada murid kita. Yeah? So their questions are always welcome. They have this feeling, and therefore they are not anxious. They don't feel anxious to ask questions. Ya, mereka tidak risau bahawa bila mereka tanya soalan, mereka tidak ada kerisauan. Okay, so kita mau budaya ini, di bilik darjah kita. And when one person asks question, the others appreciate by listening to the question. We want this type of culture. Okay, and we don't forget to praise them for asking questions. Because when we praise them, we demonstrate to them that we actually value their questions very much. Budaya ini kena ada. Yeah? And we also teach our students about open-ended and closed questions. Okay, so ask investigable questions, all right? Provide examples of question stems to them, yeah, so that they will be trained to ask open-ended investigable questions. Yeah, of course, sometimes closed questions. All right, we need to slow down to leave room for questions. Yeah, we shouldn't be talking all the time. Yeah, we should leave room for students to talk. Yeah, of course, their talking is about what they are learning. Provide opportunities to practice asking questions. All right, that means we as teachers, we identify and we refine their questions. We will not judge their questions, but we will always refine their questions. For example, we turn non-investigable questions to investigable questions when there is an opportunity. Yeah, include time for student reflection. Yeah, let them have some time for reflection. Yeah, they can discuss with their peer. Okay, try alternatives to are there any questions? All right, and we kept asking about these questions. Are there any questions? And most of the time, we do not get any question. Okay, and in fact, this phrase discourages our students from asking questions and doesn't help them and doesn't help us to evaluate what they understand because there are no questions from them. Okay, now these are helpful suggestions from Harlan and Poulter on how to handle students' questions. Yeah, the questions may be philosophical. Yeah, the questions may be religious. Yeah, religious question, philosophical questions. So we tell the students, we validate their question. Okay. We still validate their questions by acknowledging that they have asked interesting questions. But at the same time, we point out to them that this is not a question that scientists can answer. Yeah, for example, a religious question. And this will help children to appreciate that science has limits. And there are questions that scientists have no tools to answer. Okay, and next we have complex questions. Complex questions are questions with complex info. Yeah? But these questions can be turned into related investigable questions by identifying variables that are relevant. Okay. Now, for example, why does the magnet stick to the nail? We can identify two relevant variables. One is the characteristic of the magnet. All right. We can manipulate the characteristics of the magnet, the shape, the size, and so on. And another one is the material in which the nail is made up from. All right, it's whether it is an iron nail or nail that is made up of other materials. Okay, so we turn into why, and we turn why into what would happen. See, we turn why into what would happen. Okay, what would happen if, okay, we change one of the variables at a time? Okay, what would happen if we, for example, bring the magnet close to something? Or what would happen if we do something to the magnet? Yeah, for example, we cover the magnet with masking tape and so on. That means we are changing one variable, which is the characteristics of the magnet. And then the next one would be, we can change the other variable, that is the materials in which the nail is made from. Okay, so next, Leon. Okay, so by changing the first variable here is the magnet. Yeah. So what would happen if we put another object or metal close to the nail? What would happen if we put a smaller magnet close to the nail? What would happen if we put a magnet covered with masking tape close to the nail? So here we have manipulated variable, and we will see what happened to the nail. Okay, by changing the second variable is the material which the nail is made from. Okay, and the following questions may come up. Okay, what would happen if we put a plastic nail close to the magnet? All right, so we change the material the nail is made from. And what would happen if we put paper next to the magnet? That means we have nail, we have paper, and we have other objects, yeah, instead of nail and paper. And what would happen if we put a wet nail close to the magnet? So all these are investigable. Okay. This question model asking questions that lead to developmentally appropriate practical investigation. All right. It is very practical because you have the material and the pupils have the time to conduct the investigation with the easily available materials. So it is very practical, okay? And it will broaden a child's understanding of the various factors that affect the interaction between a magnet and different materials. And as a result, the knowledge is constructed from the investigation. All right, I hope it's clear. Okay, next. Okay. Next, questions requesting facts, names, etc. So these are questions that request basic info. So we can just give the students answer, or we can give them appropriate reference material, all right, and let them find out, and which is actually good, yeah? Better than just give them the answer. Yeah, sometimes we can ask them to do a document analysis in order to get the answer, yeah, in order to get the facts and names and so on. All right, next. Okay, now there are 3 types of investigable questions. One is descriptive, okay, descriptive, okay, and there are examples of question stems here, okay, and some examples of descriptive questions. Yeah, what kind of food do birds eat? Okay, does brown sugar dissolve in water? And what happened to the leaves of maple trees when it snows? Okay, and the next type is Leon. Okay, the next type is relational. relational questions. And these include identification and classification questions. Okay, comparison questions, correlational questions. Yeah, so I think you can understand this, huh? Relational questions. Okay, for example, how are these leaves similar and how are they different? Comparison questions. Okay, how is the height of a plant related to the number of leaves? Relational questions, but not cause-effect relationship. Okay, we will see cause-effect relationship in the next slide. Leon? Cause-effect. Does this affect that? Yeah, for example, okay, does increase in temperature increase the rate of photosynthesis? Yeah, for example, so cause-effect questions. Yeah, does sunlight affect the growth of a plant? And how does temperature affect the rate at which salt dissolves in water? Okay. Leon? Okay. Now, you can evaluate your question by using this checklist. Okay. So we can do a self-evaluation by using this checklist. I ask myself whether my questions are interesting. Because good investigable questions are very interesting. Yeah, they are so interesting that they will spark the students' curiosity. So we are also able to evaluate the questions from our students. Yeah, and if they are not so good, then we can actually fine-tune for them. Yeah, we can discuss with them to make it a more interesting investigable questions to pursue further investigation. Yeah, all right. And there are those questions that we do not already know the answers, and as a result, investigation is needed to find answers. Okay. So good investigation questions are actually questions which lead to a plan of action. That means after we have identified the questions or problems, or we use problems, yeah, in scientific, in kaedah scientific method. Yeah, from observation, we have questions. And a good investigable questions will enable us to plan an experiment, for example. So we will know, we will plan, and we will have the procedures for us to investigate. All right? Okay. How to collect data and so on. Okay, good investigable questions are those that can be answered with available material, and this is very important. So, after the students have asked the investigable questions, after we have murnikan soalan-soalan murid kita, not only one, maybe a few investigable questions, and we can divide the whole class into a few groups, whereby each group will be investigating and finding answers to their own questions. But at the end of the day, they will come together to share their hasil penerokan. Yeah? Okay, so But we have to make sure that we have the materials for them to do the investigation. So that is very important. And good investigation questions are those that can be completed in a reasonable amount of time. So when we look at the last two items of the checklist, we get the two basic requirements. And these two requirements are namely available material and reasonable amount of time. Okay, Leon? Okay, so I have example of non-investigable questions and investigable questions. Okay, example, okay, why do some butterfly cocoons hatch, and why some butterfly cocoons do not hatch? So it is a non-investigable question, okay, which requires info, requires explanation over a hands-on investigation. Yeah, there is no need to do a hands-on investigation. Yeah, it doesn't mean that this is not important, but the students will be able to gather information from various resources, yeah, in order to get answer to this question without having to do a hands-on investigation. But we as teachers can turn it into an investigable question, such as, does the air temperature make a difference in how fast a butterfly cocoon will hatch? You see? Then these require further hands-on investigation. But we may not have butterfly cocoons, so we can always use another substitute. So we have to look at available materials. Okay? And then, when is the appropriate time to do? Yeah, it can be carried out as PBL, project-based learning, over a specific period of time, yeah, over the school holidays and so on. Yeah, they can actually bring the materials with them and they can observe over a period of time as a project-based learning. Okay? All right, okay. Next. Okay, so we go further to whether a question is investigable or not. Okay, investigable means it leads to a test. That means it is testable. Okay, how do plants grow? Not testable. What prevents ice from melting? Is not testable, but it can be, both can be converted to testable or investigable question. So, will aiding fertilizer make plants grow taller? All right, okay. And what is the best insulator to keep ice from melting? So, non-investigable questions are turned into investigable questions, which require or which enable the pupils to do hands-on investigation and construct knowledge from them. Okay, next. Okay, so when we turn non-investigable questions or non-testable questions into testable or investigable questions, we have to change something. And when something is changed, what could happen? So the manipulated variable, for example, the first one is you add fertilizers and you don't add fertilizers. Or you add more fertilizers, you add less fertilizers, you don't add any fertilizer. So you actually change, all right? Change the variable, okay? And whether the plants grow taller as a result of the change, or the plants do not grow and so on. Yeah, as a result of the change, what could happen? Okay, so I think you can understand. Yeah, definitely you can understand the manipulated variable and the responding variable. And by doing this kind of hands-on investigation, they actually can identify and control variables more effectively. Okay, Leon, next. Okay, a few more examples. Okay. Does a fish get angry? Does a fish get angry? How do we know? We don't know whether a fish is angry or not. If you take away its food, so definitely it is not testable because we cannot measure fish anger. Yeah? It must be something that we can observe and we can measure. But if we rephrase, and it will become investigable. Do fish lay more eggs if they have more food, or do fish lay lesser eggs if they are given less food? So you can do that. Yeah, you can investigate. All right, and let's go to the next one. Do plants like water? Do plants like water? So we don't ask, isn't it? It is not objective. Yeah? Do plants like water? But instead, mungkin cikgu boleh cuba, how do we change this into investigable questions? Okay, maybe I would appreciate if someone leave your response in the chat. Do plants like water? And you would like to convert this into investigable question. Boleh? Cikgu Alice? Cikgu Alice? Tiada? Cikgu Alice hanyut sudah? We use the istilah hanyut. Okay, Cikgu Leni Chin. Cuba. Cikgu Leni Chin. Hello. Cikgu Lizam. Halo. Ada kan? Tiada kan? Cikgu Maisim. Kali kedua saya panggil Cikgu Maisim. Cikgu Maisim, kalau masih ingat, dua orang guru pelatih saya ditempatkan di sekolah Cikgu Maisim, iaitu kalau saya tak silap Nizam dan Mek Lee. Betul tak Cikgu Maisim? Tiada orang mau layan saya. Okay, ada. Very good. Cikgu Azman. Makin ramai respon ni, bagus. Okay, do plants like water? Not testable. You are right. How many cups of water does a plant need to grow? Bagusnya. Cikgu Maisin. Betul kan saya? Nizam dan Mekli yang dihantar ke sekolah Cikgu Maisin. Kalau saya tak silap lah. Okay. Cikgu Marhani, cuba. Okay, saya suka jawapan Cikgu Marhani Marhani. Okay. So does a plant grow quicker or more quickly? Apabila disiram dengan air dengan lebih kerap. I think itu jawapan, itu soalan yang testable. Boleh? Okay. SK Bundung. Okay. SK Bundung. Okay. Cikgu Vu, will plants die if they got too much water? Alright. Investigable? Yes. So you will do a variable scan. Okay. Your variable scan will be, for example, Cikgu Mahani. Bilangan cawan air. Bilangan cawan air. Tetapi mungkin kita akan seperti video tadi kita akan tanya murid, adakah lebih baik kalau kita sukat air? So kita ada isi padu air. Boleh? And then you must fix the variable, jenis tumbuhan. Jenis tumbuhan. Now you see what I mean? So from one question, it leads to other question, and finally you can, finally the class agree on one questions and do an investigation to find answer to the question. Okay? All right. How about, will sleep affect a student? Will sleep affect a student? Okay. Thank you, Cikgu Marhani. Well done. Will sleep affect a student? Okay, response from anyone? Cikgu Asme? Is it testable? No. Very good. Cikgu Asman. Bagus. Okay, bagaimana kita tukarkannya kepada investigable question? Okay, variable dia bilangan jam tidur kan? Bilangan jam tidur, variable-nya. Tetapi apa yang kita nak kaji? Kita nak kaji bilangan jam tidur pelajar IPG Campus Kent dengan keputusan mereka dalam peperiksaan Jun 2022 yang akan datang. So it become an investigable questions. Okay? Does a student perform with a better score in fundamentals of chemistry if they sleep for 8 hours per day? something like that. Okay, let's see Vu's answer. Okay, how many hours of sleep that a student need to keep healthy? Masih boleh dimurnikan, right? Sebab healthy itu agak tidak cukup spesifik. Tidak cukup spesifik. Boleh ya, Cikgu Vu? Good try. So hours of sleep is the manipulated variable. So the responding variable that you can measure, for example, their score in certain subject, for example, in certain examination. Is that clear? I hope so. Bolehkah? Okay. Okay, and the next slide, I will be telling you the two requirements. Next, this one we have already discussed. Okay, next slide. Okay, next slide is we must make sure we have materials and time. Okay, this example, we have the time, but we don't have the material. And the material is swimming pool. Okay, but you can always change it. Can a person balance on 1 foot longer if they are standing in, somewhere else, not the swimming pool? Because the school most likely will not have a swimming pool. So this is an example to show us that our investigable questions must fulfill the material required. Okay, next, Leon. Okay, does eating a power bar, power bar, okay, yang bagi kamu power itu, ataupun does drinking Red Bull affect your balance? So it is testable, all right, and it meets both time and material. Power bar ada, masa pun ada. Okay, all right, okay, and then let's look at the next one. Can people balance on 1 foot longer if they practice every day for a year? Okay, so it can be investigated, but the time is 1 year. So the constraint is time, and the students may not have 1 year because they have holiday in between. So this is an example that shows you that certain investigations cannot be done because of time constraints. Okay, and the last one, does being sick make your balance worse? Okay, it's all about balance. Okay, and this is testable, of course, but you can only do the investigation when someone falls sick. So the constraint is there. That means the material. The material to carry out the investigation is you have to get someone who is sick. Okay, so these are examples that shows us that we need to be aware of the materials and the time. When we want to do an investigation based on the investigable questions from our students, which you have actually facilitated. Okay, I have come to the last slide actually. Okay, and before all this I have discussed. Okay, I have actually come to the last slide, but I would like to see any response from any one of you. I welcome questions from any one of you. Okay, moderator, I pass to my time to my moderator, Ishin, before I end question and answer session.
Kita akan terus beralih ke sesi soal jawab. Sekiranya para peserta mempunyai soalan, peserta boleh menaip soalan tersebut di ruangan in-call message.
Okay, you may send your question to me. Okay, very interesting question actually from Cikgu Azman. If they have less sleep, do they have enough sleep? So I think it depends, because certain individuals need less number of hours, while certain individuals need more number of hours. Okay, thank you very much, Cikgu Azman. Ada soalan lain? Moderator, ada soalan? Mungkin kan? Mungkin moderator ada soalan.
Alright. So, Mr. Tan, my question is, how do we write an investigable questions?
Okay, that is a very good question. Okay, cikgu-cikgu mungkin mau share. Cikgu-cikgu yang berpengalaman ni. Cikgu-cikgu ni sangat berpengalaman. Mungkin mau share. Okay. Ataupun mungkin cikgu-cikgu mempunyai jawapan yang sama dengan jawapan saya. Okay, now remember we always ask question which we want to find an answer, isn't it? Correct or not? Why do we ask questions? Okay, because we want to find the answer. And the next step, you have to do some background research. Am I right? We are all the same, right? Okay, after we have the question in mind, we will gather information. It means we will do some background research. Okay, and after that, we write down the hypothesis. So we formulate the hypothesis. So don't forget, after the questions, the investigable questions, we formulate hypothesis. Okay, and from the hypothesis that we have formulated, we actually do a variable scan. We identify and we control the variables. Okay? So I hope I have answered your question. So basically, the question is written, or the question is in your mind, and then you do some background research. All right? And from there, you formulate hypothesis, all right, which shows the relationship between the variables after you have done a variable scan. Okay, all right. So that is how you write. That is how you write an investigable question. Okay, I hope I answer your question.
Yes, thank you, Mr. Tan. So I would like to ask another question. So how do we know a science question is a good one?
Okay, a science question is good if it is objective and testable. Testable one, that means it is investigable. But of course, apart from investigable questions, teachers do ask a lot of non-investigable questions. The reason why teachers are asking investigable questions is because the current emphasis is on inquiry science education, IBSE, inquiry-based learning, IBL. Okay, higher order thinking skill and open investigation. These are all the emphasis in our science in the 21st century. So we must train our students to ask investigable questions, and then they will do the investigation. And while doing the investigation, they actually find answers to the question, which either result in accepting or rejecting the hypothesis. Understand that? Okay. So a good science question should be objective and testable. Okay. It may be verification question. Yeah. It doesn't mean that it has always to be testable questions. It may be verification questions. It may be theoretical questions. It may be experimental questions. But whatever it is, it should be narrow enough to answer with data collected by observation and by testing. Okay? And it should not be a question about our own opinion. It is not about our opinion. It is about data gathered by observing or by testing to answer our formulated hypothesis. Okay? So,
alright. Thank you so much, Mr. Tan. Jadi, hadirin sekalian, ada soalan lain untuk ditanya?
Oh, Cikgu Asman was my ex-student. Oh, Asman. Pelajar matematik ke Asman? Okey. Apa kabar? Saya observe Azman ni semasa di Nongkolot. Betul kan? It's proven that I'm still young. I can still remember all of you. Okay. More question? If not, okay. Okay, if not, next slide. I love this kata-kata keramat. Next slide, Leon. I like this. I'm not good in pantun. Saya tidak pandai pantun. Yeah, but I would like to share this with every one of you this afternoon. We actually all work for a cause. We don't work for an applause. Yeah, tidak ada applause pun tidak apa. We live life to express and not to impress. We don't strive to make our presence noticed. We just make our absence being felt. Kalau kita tidak hadir, anak murid kita rindu kita. Ya, kalau kita tidak hadir, anak murid kita happy menari, that means something is not good lah. Ya. Okay, ataupun budak itu sakit tetapi tidak mau pulang walaupun disuruh pulang kerana dia ingin dia menanti cikgu masuk kelas tu. Boleh ya? Itu maknanya. Sungguh bermakna ini ya. Okay. So I thank you very much for your time. Alright. And together, let's become part of the ripple effect in spreading the goodness of education. And I love this beautiful quote. Okay. And unselfishness is the most beautiful trait, yeah, the most beautiful personality trait. Yeah, I love all these quotes, and I think it actually helps us, yeah, as educators. Thank you very much for your time. Yeah, thank you very much for listening to me. I am never an expert, but I'm always willing to share what I have with the teachers. And thank you very much, yeah, teachers, for teaching the children out there. Yeah, you can make a difference. Thank you very much.
Baik, demikianlah sisi perkongsian bagi slot STEM Fiesta 2022, iaitu Raising Questions and Changing Non-Investigable Questions to Investigable Questions oleh Encik Tan Cucu sebentar tadi. Terima kasih saya ucapkan atas perkongsian yang sangat baik dan padat. Jadi sekarang, mari kita teruskan dengan majlis dengan gimmick penyerahan sijil. Sebagai tanda penghargaan, mari kita sama-sama saksikan video penyampaian sijil penghargaan kepada Encik Tan Cucu. Setinggi-tinggi penghargaan khas kepada Encik Tan Cucu, tenaga pengajar utama IBSE, selaku penceramah bagi slot Raising Question and Changing Non-Investigable Question to Investigable Questions pada hari ini. Diharapkan ilmu dan ilmu yang dikongsikan akan memberikan manfaat kepada kita semua. Dengan gini pengerahan sijil sebentar tadi, maka berakhirlah slot kita pada hari ini. Sebelum majlis bersurai, para peserta diminta untuk membuka kamera masing-masing bagi sesi fotografi. Sementara menunggu persediaan para peserta untuk sesi fotografi, diingatkan para peserta agar tidak lupa untuk mengisi link kehadiran dengan menggunakan tautan yang telah disediakan. QR code juga ditayangkan bagi memberi peluang kepada peserta yang menggunakan live stream untuk mengisikan kehadiran selepas. Jadi untuk makluman hadirin sekalian, tautan kehadiran akan ditutup sehingga jam 6 petang hari ini. Terima kasih. Dengan itu, pihak kami ingin mengucapkan berbanyak-banyak terima kasih atas kerjasama yang diberikan oleh para peserta. Pihak kami juga ingin memohon maaf sekiranya terdapat sebarang kekurangan sepanjang slot ini berlangsung. Sebelum slot ini ditamatkan, saya berharap agar semangat para peserta tidak berakhir di sini kerana masih terdapat banyak lagi slot-slot yang menarik dalam STEM Fiesta 2022 ini. Itu sahaja daripada saya, Tan Yishing, moderator pada hari ini. Mohon maaf atas segala kesilapan. Diingatkan sekali lagi agar semua peserta dapat mengisi link kehadiran dan peserta yang menggunakan live stream menggunakan QR code untuk mengisi kehadiran yang sudah dipaparkan sebentar tadi. Sebelum menutup majlis, marilah kita bersama-sama menyaksikan video penutupan.
Terima kasih kerana setia bersama dengan kami sehingga ke hujung siaran ini. Ingatan mesra, sila isi link kehadiran yang telah dikongsikan melalui ruang chat live siaran ini. Isikan butiran dengan tepat seperti nama penuh, nomor kad pengenalan dan juga alamat email yang tepat agar urusan penghantaran e-sijil anda dipermudahkan. Link kehadiran akan ditutup tepat pukul 6 petang pada setiap hari siaran. Sebarang kelewatan dan kecuaian adalah di bawah tanggung jawab Anda sendiri. Sila rujuk tentatif program STEM FIESTA 2022 ataupun klik my link di pautan INFO HUB STEM FIESTA 2022 agar tidak ketinggalan program-program menarik yang disajikan. Semoga bertemu lagi dalam program seterusnya. Salam hormat, sekian, jumpa lagi.